So hi students, welcome back. In this part, we are going to see the different forms of straight lines and their various applications which are involved in solving questions of JEE Mains and JEE Advanced. What we will see in this part, we will see the normal form, the parametric form, the point slope form, the 2-point form and various other forms of straight line. So go deep into this chapter, stay tuned. Now we will do some of the terms that is being continuously and rigorously used in the chapters of straight lines, which are an integral part when we are going through the complete chapter. Some of them are the intercepts on the x-axis and the y-axis like this. So see, for this type of thing, what we have to do, first of all, we have to assume a rectangular axis. So these are the rectangular axes, x-axis and the y-axis. So first of all, we'll consider a line cutting the axis in A and B. This is y o y dash, x o x dash, and A and B are the points on the x-axis and the y-axis respectively. So OA, the point from the origin and the point where the line cuts the x-axis, is called as the x-intercept. OB, the point from the origin till the point where the line cuts the y-axis, is called as the y-intercept. So OA and OB are the x and y intercept respectively. So now let us move towards the different forms of line. The first one is the slope intercept form. So in this we have to consider a line making an angle theta with the x-axis and intercept with the y-axis. So what I am saying over here is that I have a line which is making an angle theta with the positive direction of the x-axis and has an intercept of c on the y-axis. So this is how the line is going to look like. So this is angle theta which it is making with the positive direction of x-axis and that too in the anti-clockwise sense. So this will come inside the tan argument. So tan theta m is the slope. See, as described above, the intercept on the y-axis, this is the origin and this is the point where it intersects the y-axis. So this is C and this is the y-intercept, right? So moving on, we can see, first of all, we'll consider a point on the line. That is, suppose the considered point is Pxy, and then we'll try to write the equation of line. The slope of the line as described above is tan theta, and tan theta can be written as the vertical motion in the y direction upon the horizontal motion in the x direction. As you can see over here, the vertical motion is nothing but the y minus c part, because this is the y intercept and this we are taking from the origin itself, so this will remain like x. So as you know, this general notation of slope is m and this is I have written in the form y minus c upon x. So while I do the cross multiplication, I can say that m will get multiplied with x. This is what I'll get in the end, y equals to mx plus c. So this is the equation of line in the slope intercept form, where m is the slope and c is the intercept on the y axis and coefficient of y is equal to 1. See, what we can do over here, we can do a bit of change and I can also write this as y equal to m times x plus c by m. So this is the same line which is making an intercept of minus c by m on the x-axis. This information can also be extracted out from this line. So let us solve an example. We have to find out the equation of a line which makes an angle of tan inverse 3 with the x-axis and cuts off an intercept of 4 unit with the negative direction of the y-axis. See, there is an important term which is being given over here, intercept. Intercept is nothing but a distance, and distance is always positive. So whenever you have been given the intercept, always try to see the direction in which the intercept is given, right? Because suppose if a line is making an intercept of 4 on the x-axis, this intercept will 4 might come over here as well as over here. So direction is also important. So as you can see in this question, it is given very specifically with the negative direction of the y-axis, so which will help us. And theta is given as tan inverse of 3. So we'll use the equation of y equals to mx plus c, where m is the slope and y intercept of c is minus 4. So the required line will be nothing but y equals to mx plus c, and we have just jot down the values of m and c. M is 3 and c was minus 4, hence the equation of the line y equals to 3x minus 4 is the required line. Next in the series is different forms of line. So first of all, we will start with the point slope form. What do we do in this line? First of all, let us try to figure out what do we have with this. We have the coordinate axes and a point P from where the line is passing, and the specific value of slope m, that is tan of theta. So first of all, you have to consider a line passing through point P x1 y1 and having a slope of m. Next, what we will do, we will try to find out what will be the general point on that line. Suppose the line that we have is this, which is shown by the yellow color. Suppose this is the line that we have, and this point P is on this line, and the theta is this. So we will take any general point Q on this line, that is xy, and try to write the value of tan theta as difference in y coordinate upon difference in x coordinate. So slope m now can be written as y minus y1 upon x minus x1, and the value of this is going to be m because that is given in the question. Now what we can write, that y minus y1 will be nothing but m times x minus x1, and this can further be written as y equals to mx plus y1 minus mx1. And mind you that there will be only one line that will pass through the given point and the given slope. So only two conditions are required for defining a line. One of them is the point information and the other one is the slope. If we have these two information, so we will fix any line. So let us see the other format, 2-point form. So let us apply our mind and consider what we can do to find out the equation of line in this format. So let us again consider we have a coordinate axis and we have 2 points P x1 y1, and suppose Q is there x2 y2. Now we have this. As our knowledge, I know that the value of slope is nothing but the difference of the y coordinate upon the difference in the x coordinate. So in this, what is only missing is the value of m as compared to the last format. So m I can find out using these two values, and the whole process is going to remain same how we found out into the last process. So first of all, we'll consider a line passing through point P x1 y1 and Q x2 y2. Then slope can be written in the format of y2 minus y1 upon x2 minus x1 as difference in y coordinate upon difference in x coordinate. So using the point slope form again, where m was specified to us, but in this case we have found out m, the equation will look like y minus y1 equals to y2 minus y1 upon x2 minus x1 whole multiplied by x minus x1. There is very important property. If you will see that this is nothing but x minus x1 y2 minus y1 upon x2 minus x1. So if you think that this is nothing but the ratio, try to do alternando. So if you will do the alternando, you will see this is nothing but x minus x1 upon x2 minus x2. So what I am trying to explain over here is that it is nothing but a ratio. We have considered a general point, suppose r, that is x, y. So what we have thought that if the person travels from this point to this point and this point to this point with a fixed velocity, so the distance covered is always going to come in a specific ratio. This what you can take out pictorially and geometrically from this ratio. Moving on to the next part, intercepts form. As we have just learnt intercept into the past slides, so let us see how this intercept form is going to look like. So first of all, we have to consider a line making intercepts on A and B on the axes. So first of all, let us consider the axis, and these are the two intercepts about which I am talking about. P is the point P which is on the line, and this is the final format. This is how the line is going to look like. So let us learn this process step by step how we are going to do it. So first of all, we will consider the coordinate axis, and as given by the information, we will try to see the intercepts. So this is the x intercept, that is of the value A, and this is the y intercept, that is of the value B. So what we have to do now, we have to consider a point on the line. So we have considered a point P xy on it, and vertical distance will be the y coordinate and horizontal distance will be the x coordinate, very well known to all of us. So now I can see that I have formed a triangle that is OPV. So let us see the specifications. The triangle OPV is, this is the point O, this is the point P, and this is the point B. This is the triangle OPV, and the next thing is triangle OPA. So this is the point O, this is the point P, this is the point A. So this is the triangle OPA. And now in totality, if I'll add both of these, I'll get a triangle that is A, B and O. So what I'll do, I'll write out the area and equate them. So area for a triangle is half base into height, very well known to us that area of a triangle is nothing but half base into height. So for this triangle, if the base is B, so for this triangle, if the base is B, so the perpendicular height is X, and for this triangle, if the base is A, the perpendicular is Y, and for this triangle ABO, as we all can see, it's a right angle triangle, so both the sides will be written like A into B. Let us see what the next step is. Next step is half into bx plus half into ay, that is equal to half into ab. And if I can cut down all the halves and divide this whole equation by ab, I'll get x by a plus y by b equal to 1. How to remember this? If the intercept on the x-axis was a and the intercept on the y-axis was b, just divide the variable by the intercept, add them up and write it equal to 1. This is how you can remember the equation in the intercept form. The next in the order is normal form. It is one of the most important forms of line as far as all the formats of line is concerned. So let us see how we write a line in this form. So consider a line meeting the axes at A and B at a distance P, that is OQ from the origin, making an angle alpha with the x-axis. Next in that, we have to consider a point on this line, and then we have to draw certain perpendiculars that will be part of construction to get to the final equation, and that will be PL perpendicular to OX, LM perpendicular to OQ, and PN perpendicular to LM, and the angle PLN is going to be equal to alpha. So let us represent the whole of this process pictorially. Suppose this was the point A and B, and from origin I have dropped a perpendicular on this line which will intersect the line at Q, and this is nothing but the length P of the line, and it is making an angle alpha with the x-axis. Now after that, what we did, we have drawn certain perpendiculars after considering a general point P on the line. Suppose this was the general point P which was considered on the line, and PL was perpendicular to the x-axis, LM which is parallel to the AB perpendicular on OQ, and PN perpendicular to the LM. So from P I'll drop a perpendicular on the LM, an angle PLN. So this angle will again become alpha from geometry. Next, so this is the coordinate axis and the line A and B which is at a distance of P from the origin, and this is the angle alpha. Next, we will consider a general point on the line. The point P is the general point which is x and y. The vertical direction always gives us the y coordinate, so this will be nothing but y, and the horizontal one will be the x1. Now what we did, we dropped the perpendicular PL on the x-axis. From L we dropped the perpendicular on the OQ, that is M, and again from P we dropped a perpendicular on the line LM, that is PN, and hence angle PLN becomes equal to the angle alpha. So what we can say, that P is the total perpendicular distance of the line from origin. So it can be divided into two parts, OM and MQ. So OM is nothing but, consider the triangle OM and N. In this triangle, NO is given as X and angle MON is nothing but alpha. So what you can consider from the very basic trigonometric ratios, that OM by X will be nothing but cos of alpha. So OM will be X cos alpha. OM plus MQ, as you can see, this MQ is equal to NP, and NP can be found out using the triangle NPL, where PL is equal to Y and PN is nothing but Pn by Y is sine of alpha. So Pn is nothing but Y sine alpha. Hence what we can say, that OQ will be nothing but OP plus NP, and this is X cos alpha plus Y sin alpha, that will be equal to P. So the final format of this line is going to be X cos alpha plus Y sin alpha equal to P, where P is greater than equal to 0, as this was distance and distance can never be negative, right? So let's move on to the next format, distance and parametric form. See, this format of line is the ultra most important format which you must know, and this is going to help you like anything in every competitive exam. So let us learn how to write equation of line in this format. Suppose this is the line which is making an angle theta with the positive side of x-axis, and these are the 2 points Q and P. This is the assumed point, okay, and this point is the given point. So the question will generally be asked that find out a point which is at a distance r from the given point. This is the point which is given, and you have to find out a distant point which is at a distance of r, and that point can be over here and that point can also be over here, which is at a distance of r. So in this format, two things are important. First one is the distance, how far you have to find out the point, and second one is the direction, because there can be two directions, and if you have to find out a point specific, that will be finalized only after the direction is given. So let us see. If this point is given to us and this is the required point, so from the very basic trigonometry and very basic geometry, I can say that this distance is nothing but y minus y1, because this is going to be y1 and this complete thing is going to be y. Similarly, over here I can say that this complete distance is x, and x coordinate of OQ is x1, which will quantify that this distance is x1, and the remaining part is nothing but x minus x1. So from tan of theta I can write y minus y1 upon x minus x1. But now there is a twist in this story, and that twist is, first of all, we have considered that a line which is passing through Q and making an angle theta with the x-axis. After that, we have considered a point P on that line, which is at a distance of r from OQ. So all of you must remember this fact that cos of theta, the triangle that we have generated, was this, right? So this was the point Q, x1, y1. This was the point P, x and y. This was nothing but y minus y1. The x part was x minus x1. This was theta and this was r as provided in the question. So from this triangle I can very well write what is going to be the cos of theta. Cos theta will be nothing but base upon the hypotenuse. Base is x minus x1, that upon r is the hypotenuse. Sine theta will be nothing but perpendicular distance, that is y minus y1 upon the hypotenuse, that is the r. So both of the ratios, now if you take out in this format, that x minus x1 by cos of theta and y minus y1 by sine of theta, both of them will be equal to each other, and that will be equal to r. So this is how the equation is going to look like. The final equation of the distance or parametric form is nothing but this: x minus x1 upon cos of theta equals to y minus y1 upon sine theta equals to r. So you will say that this is only for a specific distance r. What should be the case if we want to find out for the general distance, right? So let us consider r not to be specific and r as any general distance, okay, and theta that is being given is any general theta. So you can write any point on the line directly without thinking twice, that x will be nothing but x1 plus r cos of theta, y will be nothing but y1 plus r sine theta, and if the direction is reverse, it will be nothing but the ratio will be equal to minus of r in place of r. So which can finally be written as x equal to x1 plus r cos theta, y equal to y1 plus r sine theta. Now let us do a question based on all the concepts that we have learned in the different formats of line. So the question says a straight line is drawn through the point 3, 2 and is inclined at an angle of 60 degree with the positive x-axis. You have to find out the coordinates of a point on it at a distance of 2 from P. So I think the question is quite clear in its sense. It is saying that you have a point P3, 2 and a straight line is drawn from this point which is inclined at an angle of 60 degree, right? So this is a line is drawn, and suppose this is the x-axis and it is inclined with the x-axis at 60 degrees, and you have to find out the coordinates of a point P which is at a distance of 2 units. So it's a direct application of the format of line which we just did. So 2 units can be above and 2 units can be down. So let us look to the solution. Using parametric form of a line, I can say that x minus x1 upon cos theta will be equal to y minus y1 upon sin theta, that will be equal to r, and hence putting up the fixed point x minus 3 upon cos theta equals y minus 2 upon sin theta equals plus minus 2, because I've told you distance can be taken in moving upward direction and can be taken while moving in downward direction. So cos theta is nothing but 1 by 2 when we'll consider theta as 60 degrees. Sin 60 will be nothing but root 3 by 2. So the points that we are going to get is x equals to 4 or y equals to 2 plus root 3, or x equals to 2 or y equals to 2 minus root 3. So as you have understood the part which is, if this is the point P, that is 3, 2. So one point we have got at a distance of 2 from over here, and the other point we have got at over here which is at a distance of 2 while traveling downwards and 2 while traveling upwards. So these are the required points. Hence let us do another type of exercise which might come in the exams. So consider that one diagonal of a square is the portion of the line 7x plus 5y equals 35 intercepted by the axis. Obtain the extremities of the other diagonal. So see, first of all try to find out the format in which you will write the line, and that will suit you best. So if you will try to write it like this, because the question talks about intercepts, so it will be best possible way to write the line in terms of intercept. So this will be nothing but x by 5 plus y by 7 equal to 1. So the line is something of this format, which is intersecting the x at a point 5, 0 and y axis at a point 0, 7. So this line is the diagonal of a square, right? And we have to find out the extremities of the other diagonal. So let us see what the question will be. So this is the final format of the line in the intercept form, and this is how the square is going to look like. So consider the axis, and it is being intercepted on the axes. So C point is 0, 7, A point is 5, 0. We have to find out the point B and D. And how we are going to find out? Because we know that diagonals of a square get bisected at their point of intersection. So it is very easy for us to find out the coordinates of the point of intersection. So coordinate of point of intersection can be written like 0 plus 5 by 2 and 7 plus 0 by 2. Hence the answer is 5 by 2 and 7 by 2. After we have found out that, we can very easily use the property that diagonals of square get bisected at the point and the remaining parts of both the diagonals are equal. So OD will be equal to OB, and that will be equal to half of the other diagonal. So other diagonal is nothing but root 5 square plus root 7 square, that is the length of the other diagonal, and upon 2 will be the part. So see how we are proceeding towards the problem. First of all, we found out the point O, and now we are finding out the distance, right? If we find out the distance R, and from the geometry I can say that this will also be equal to R. So from this I'll use the parametric form to find out these points using a single go. That is why this format of line is very important. See, while using a single equation, once you can very easily find out two different points, but that would have taken your 3 to 4 minutes in any other format. And in any competitive exam, time is the crucial factor. If anything is there which will save your time, always go for that. So the equation of VD is going to be x minus 5 by 2 by cos of theta equals y minus 7 by 2 by sin of theta equals the R. As you can see, there are two variables in this equation, but we have found out one using the geometric property of the square. And there is one more variable which is left out, that is theta, and that we will find out using another property that we have learnt in the early phases of this chapter, that is tan of theta will be minus 1 upon slope of AC. And how we have reached up to this point, as we know, if two lines are perpendicular, the product of slope will be nothing but minus 1. So the slope of the other diagonal will be equal to minus 1 by the slope of the first, because we know that diagonals of a square are perpendicular to each other. So if tan theta is found out by us, so sin theta will be nothing but 5 upon root over 7 square plus 5 square, and cos of theta will be nothing but 7 over root over of 7 square plus 5 square. The value of R we have calculated from the previous one, and that value of R is root 74 by 2. So I can use this value over there. So this is nothing but root 74 by 2, the value of R. So sin theta and cos theta is being found out by us. So the final points of the extremities is nothing but 5 by 2 plus minus root 74 by 2 into cos of theta. Cos is 7 by root 74, and y point will be nothing but 7 by 2 plus minus root 74 by 2 into 5 by root 74. As you can see, there is a common cancelling factor which you can cancel out. So this will go with this will go with this. So x will be nothing but 5 by 2 plus minus 7 by 2, and y will be nothing but 7 by 2 plus minus 5 by 2, and hence we will get the two extremities of the square. So in this part, you have seen that we dealt with different forms of straight lines and ranked them into their priority basis, giving parametric form the highest importance. In the next coming sessions, we are going to deal the congruency of straight lines and the position of a point with respect to a line. So stay tuned for further details.